Oh, are we allowed to record that? Or is that like a no-no?
Sure, yeah, I don't see why not. I'm not
Okay.
going to actually push the solution, but feel free to take pictures or record, it's okay.
Okay.
Fine. Um, it's fine.
I was wondering if you're gonna reuse the
We're going to
exam.
run one more time, and it's probably gonna be a different exam.
Okay.
So the first thing I want you to do, I want everyone who is in this room to do, because a lot of times I get the question, can you check if I committed and pushed properly?
You can just check your GitHub repo and see
And
if
you
it
can
pushed or
check,
not.
yeah, that's the kind of answer I want to give without sounding rude. I want to say, you can check it yourself. And that's pretty much the way it works.
You just log
I
in,
think
check
most
the
of it is
repo.
just like tech being tech, so if we check
Yeah,
everything.
so that being said, for example, allow me to do this, like for example, who can I pick who,
Pick me.
but you're not here.
Oh, never mind. I thought you just need
Who
someone to
is
pick
here
get
that I
picked.
can show the repo? Carl, do you allow me to show your repo to the class? Okay. So for example, Carl, we go to the repository, and we go to this exam repo and we see the commits. See, and Carl has a bunch of commits here. Well, he merged, I think we had a problem at some point, and we had to merge and then libraries and one done. See? And you should go now into the repo that you created and make sure that you made the commits. Okay, so who else is here that could, yeah, yours,
What do you mean?
oh no,
That's-
sorry, this is the home.
Oh,
Yeah, it's not the exam repo, so let's go to the exam repo.
I checked
But your home doesn't have anything committed, how is this home?
I don't understand because I checked the repo and I made sure before I left that
You're
it
probably on a different branch.
that it was committed to the
So again,
the
yeah,
submodule.
we have to check that. Again, we're gonna check Carl. And we have exam one and we have the commits here, see? Part A done, merge, part C done, whatever. So go into your repo and check. I know that there are some repos, I don't wanna give names, but I know that one person at least in this room doesn't have anything committed. So that means that you probably committed to a detached branch or something happened, so the code is still in the computer. So if that's the case, we need to fix it today. Otherwise, you won't get any mark over the weekend. Okay, so you need to check that on whatever computer, but on the cloud, check that your repo is committed. Now, I'm going to open my solution for this exam. I'm gonna go over it. Well, we're still gonna cover something about the clock. We'll see how much time we have left. We may get a bit behind the other class, that's okay. Well, this is 22.
You remember this?
Yes. All right. So if anybody from this class was joining the Saturday sessions, tomorrow will be an exclusive session for the 2250 guys. So I don't think you need to, yeah. And we're far ahead of this class, so it's not much point.
going to the repo just gives a 404 error.
So you can go into the organization and find the repo there. So that's probably a glitch. Okay, so let's take a look. So the first comment I wanna make, let me just open the exam here. Come on, I don't want to open here.
Sorry, Carlos. Is the second tomorrow gonna be recorded as well, or is it just-
Yeah, it will be recorded. I think I'm gonna probably, if I don't have any questions, I'm gonna go over there's a practice exam, the silence minute. Which just doesn't mean necessarily the our exam will be the same, but it will be.
We should cover the
Okay,
same thing.
so one of the first things that I was asking in this exam was for you guys to come up with a delay 500 milliseconds. I'm not so sure why that caused so much trouble, because if you had already a delay 1 millisecond and you had some time here, all you had to do was just sort of like divide that time in two, and that was going to give you something very close to 500 microseconds. And if it wasn't exactly 500, you could have tweaked the numbers until you were very close. That's all you needed to do. And most of you guys did that. However, just one comment. One of the things that we need to start getting used to, and in this exam for marking, I'm going to be very relaxed because it's the first exam. But from the second one, I'm going to be more demanding in terms of following the best practices. Okay. So one of those best practices is giving proper names to the functions, have proper code indentation and organization. Some of you decided to edit this function. It's okay, but do not call it delay 1 millisecond, because it's not a delay 1 milliseconds anymore. It's a delay 500 microseconds. So the names you give to the functions are important, because when there are no comments, the function name could be self-explanatory of what the function is doing. Now, if you coded a function that delays for 500 microseconds, yet you call it delay 1 millisecond, that is very misleading, right? I know that you're in the rush in the exam and trying to edit there, but that's not the right thing to do. You should copy and paste it and rename it, right? I saw that some of you had these functions already built into your library. Ideally, you would like to have a utils or utilities library to have this. You shouldn't put this inside your GPIO library, because this has nothing to do with the GPIO. See what I'm saying? It's time delays. So the best fit for it would be to be in something like utilities or whatever. Okay? Any questions up to this point? Now, these are the function prototypes. If you have libraries, these prototypes go into your .h file, whereas the implementation goes into your .c. I even saw some of these in the .h. That's not the standard. That's not what we've been teaching you. So if you're having issues creating your libraries and not understanding, make sure you reach out to me so I can explain that again to you maybe. But yeah, so that's the structure that you should be following. Okay. So the first question was very simple. It's just about implementing this 500 microseconds function and have the PC10 to toggle every 500 microseconds. Okay. So of course I have here enabled all the ports and the power interface, although we don't need the power interface yet, but and I selected pins that were easy to locate on the board, right? So PC10 or PC10, yeah, I think that one is on the top left, right? Yeah, so all I need to do is just tap onto that pin. And I'm not sure, I'm pretty sure probably this is not running yet because I changed the maybe I didn't. Okay. So if you show me something like that, probably I didn't like it because I wanted this to be Oh, somebody already pressed the auto set button here, maybe? Oh no, because the other one is not connected. So I guess I have both already connected here. There you go. So the positive width I have there is about 499.5, so it's within the acceptable range. I'm triggering on the second signal just to show both intentionally. Now this thing is covering. So, but that covers the first part, okay? Now, in the future, I'm going to be explicit in terms of asking you not to comment out code so it can be incremental, because why is the reason for that? There's one reason first. It makes the marking easier, because when I run your exam, I run everything and I mark everything at once. I don't have to be flashing and flashing and flashing 5 times just to mark one exam. Secondly, when you go into the industry, and if you ever get to program a microcontroller, you're gonna create a program that does many things, not that it just does one thing, right? So if you need to read data from the serial port and at the same time you need to, I don't know, blink some display, you're not going to tell your boss, hey, wait a minute, I'm gonna flash the other part that does this, and come back later. No, it needs to be all together. So we need to make sure that we get used to running multiple things in this big loop. In which case it's fundamental that we do not block the main grid, the infinite loop. Okay, so we keep it as brief as possible. So my time base here was going to be this delay microseconds, okay, which is a blocking delay, but for now it's acceptable. Later on, we're going to use different techniques, okay? So we just checking this part, we block the code for 500 microseconds, and we can use the same time as a time base. I saw some of you using this together with the delay millisecond, which is why when you put everything together, things wouldn't work, because I showed you long ago that as you add more delays, they just add up, right? So you need to find the finest delay and use that one as a time base, if it's possible. And I did give you the times intentionally, so they could be a multiple of that, okay? So for example, for the second part, that you're supposed to come up with a signal that is 5 milliseconds period and 2 milliseconds high, both 2 milliseconds and 5 milliseconds are multiples of 500 milliseconds, right? Because your time base is 0.5 milliseconds, right? Then 5 milliseconds is what? Times 10. And 2 milliseconds is times what? 4. 500 microseconds times 4 is 2 milliseconds. So there was no need to do a 1 millisecond delay or anything like that. You could just count. And that's exactly what I'm doing here. See, if the counter reaches the number 10, meaning that I counted 500 milliseconds 10 times, that means 5 milliseconds. So at that point, what do? I set the pin, so I set it high. Because it should always start high, right? And then, when the counter reaches, what is the other value? Oh, this is the period, okay. The high time, well, this is already including the part 3. See, this is why I tell you that all the things could be incremental and you wouldn't have to comment out any code. The high time starts at 4. Right? So 4 times 500 is 2 milliseconds. So when the counter is 2 milliseconds, this should clear. By the way, the pin should start high. I don't know if I start high actually. I don't. I should probably start high.
What is it that's setting it? Or is that
No, that's the LED.
Oh, okay.
So let's do that. GPIO set is PC10, right?
Yeah, GPIO-C 10.
Yeah, because that will allow me that the first time it starts high. Well, you're not gonna notice that when you run the program, because then it's gonna be only one time, then it's gonna adjust. But anyways, it's gonna start high, and after the high time, which is 4 counts of 500 microseconds, meaning 2 milliseconds, should clear it. So it starts high. After 2 milliseconds, should clear. And then 5 milliseconds should be set again. And then after 2 milliseconds, clear again. But all of this, it's happening at chunks of 500 milliseconds. So 1 500, 2 500, 3 500, 4 500, so on all the way up to 10. Okay? So that way, you didn't need to use any other delay, just the 500. That was the perfect solution, not because I'm saying I'm perfect, but that would have been the perfect solution in my opinion, the one to expect, the one that has the least overhead. Okay? And can run all the things at the same time. So once you show that there, you noticed that no behavior affects the other. So they both run at the same time, part A and part B. Moreover, part C, what is it asking? Part C is just asking to check the PC13 as an input and turn the LED on if it's checked. So that part is here. So forget about what I have in the middle first, but what I have in the if else. If the button is pressed, LED set. Sorry, if the button is the button is active high. I forgot that. If the button is pressed, I should say here button pressed.
But the button was active low.
The button is active low. The LED is active high. Because it goes through a transistor, remember? Yeah. For the button board is different. Okay. So when the button is not pressed, then we clear. That's it. And that's going to give us this behavior. And this behavior was supposed to be very responsive. See? It cannot be taking any delay. If you were blocking the code for 2 milliseconds, then, well, you couldn't notice either, to be honest.
On 2 milliseconds? Yeah, probably not.
Yeah. Anyways, then after you get that, see, that's already, at this point, that's already 70 marks. Okay? So the last part actually is the only most challenging, just the part D, which is 30 marks. Where you have to, in the first part, use the switch transitions and count. Okay, and for that we needed to use a state variable that we did give you some examples, so it was just a matter of checking that. And we have this button state variable that starts at 0. Okay, if it's first detected pressed, meaning that it was not pressed before. If not button state, then I set the button state to 1 and I count the press. Okay, then if the button is not pressed, I'm going to check if it's the first time that it's not pressed, in which case I reset the variable, right, with this part here. That is for the state detection. Now, when I detected press, I'm going to send the printf to the console, which is happening here. See, I'm kind of using a combo here because I ask you first to use the printf to the console and then do the sprintf. But of course, when you do the sprintf, you're printing into this array, which needs to be large enough. In this case, for me, it's 32 characters, so it's large enough. You send the button press number, okay? And after that, since already it's in the array, you can also send it to the terminal and to the debug terminal, to both, because it's the same message. Let's give it a try. The important thing here was that this needed to be connected at 115/200, so that's not the default for Teraterm. What the heck? I think I selected the wrong thing. So set up terminal, not that, so that serial port. We set it to 115/200. And then I start pressing buttons. 1, 2, 3, 4, 5. So doesn't need any debouncing. It's good enough. and it shows the same thing on both. That was the 20 marks, right? So at that point is, at that point you get 100%, right? Any questions up to this point? And then all I have to do, it was to toggle the state of this when I press the button. So instead of being, let me see if I can show this. Instead of being, so right now it's 3 milliseconds high, 2 milliseconds low. The periods shouldn't change, only the high time changes from 2 to 3. When I press, it changes 2, 3, 2, 3, and so on. Every time I press, it changes. Okay? The period is maintained. So what am I changing when I press? Well, all I change is this high time. Okay? Now, what am I doing an exclusive OR with 2? That's a fancy thing I just did. It's because high time, what is originally?
4.
4 originally. Okay, so 4 is this number, right? Do we agree?
Yes.
Then we want to toggle between between 4 and what?
6.
And 6. Excellent. Yeah. So 6 is very similar to 4, except it has an extra 1 there. So if I toggle with 2, which is actually this number, see what I'm saying? Because when I exclusive OR with a 1 here, this bit in particular, bit 1, is going to toggle between 1 and 0 because I'm doing exclusive OR. So therefore, this thing is going to change between 1, 0, 0 and 1, 1, 0 and back and forth. Now, of course, you could have used a state variable, something like if, whatever, and it's 4, now make it 6, or something, whatever logic you used. It's also acceptable. I just wanted to show you that when you look at the difference between 4 and 6, there's only 1 bit difference. So therefore, you could have changed that with just toggling with the proper binary. Okay? And that would have been super efficient. And the code itself, well, with the functions included and everything that I had, which I didn't even use because I could have just removed, you know what, let's just remove the 1 millisecond delay because I never needed it, right? I just needed the one function. Isn't that correct?
Okay.
So even including all this stuff with the includes and the comments and these variables, my code goes only down to, up to 112 lines. So when you have code for an exam that is going over like 300 lines, so definitely something's going wrong, right? You have so much stuff commented out and things repeated. Remember that the approach here is to write efficient code. Even this, I didn't need the whole thing. Oh. CPAOP. Any questions about this implementation?
No, it's super clear now that we can see it.
Yeah. Probably the biggest takeaway from this exam is like, once you already have a time base, do
Stick
not
with
use
that.
a different delay, just count.
Only 1.
Yeah, if that time base is good for everything, why not? In fact, it's very typical, like in any application, for example, to have a 1 millisecond tick. Any firmware application, even if you're running the big infinite loop, if you're doing a real-time operating system like an RTOS, whatever, always the 1 millisecond tick. In this case, I just gave you a half a millisecond tick, just because I had given you already the way of doing it. So it would have been too easy, right? So I needed to make you think a little bit more. And once we have that tick, once we have that 1 millisecond tick, There are certain things that need to run really fast. There are some others that don't need to run really fast. So all those little tasks that you have in the infinite loop, they will have sort of like a counter. They will say, is it time for me to run? You know what? You're gonna run every 100 ticks. You're going to run every 50 ticks. You're gonna go faster. You're gonna run every 10 ticks. So then each individual task that you have is gonna count those ticks. Is it 10 yet? Oh, is it time for me to run? Okay, I'll run. And that way you keep a loop that is smooth enough and it's always checking if it's time to run. If it's not, you won't do anything. You just keep looping. Rather than, let's say you have a task that is supposed to run every 50 milliseconds. The terrible approach would be to block the code for 50 milliseconds just for that thing to run, right? Because it will block anything else. Everything else. And that is the biggest problem. You want your program to be responsive to button presses and all that. And the moment that you start adding blocking delays, things start to get not responsive. Okay. Same thing for the state variables. The idea is to check the transition of the variable, right, from low to high, and vice versa. Not to be blocking, because some of you were trying to block there just to detect the one button press. No, that's not a good approach. That's not what we want.
Nope.
All right. Any questions, comments? Too difficult, too challenging? What can we improve for the remainder of the course? So we got.
Maybe just the amount of practice time that some of us need to put into.
Oh, yeah. Thank you that you brought that up. When I give you those activities that are not mandatory, some of you decide to engage in the activities, and normally the ones that engage in the activities end up being successful. The ones that just decide to go home because they don't want to do the activity, then, well, they encounter something similar in the exam, and at that point they need to start figuring it out. So if I give you the activities, they are for a reason, right? And they are for you to explore the things. Because if I talk for 2 hours, everyone's going to be falling asleep by the end of the class. And secondly, you're not going to be able to digest and explore the things yourself. So key aspects to succeed in this course, I talk from the experience of being taught this course many, many times. Do not skip class. So try to stay on top, because skipping one class could cause you get lost in the content. And secondly, do the activities that we give you. Now, what I noticed for this exam, I haven't yet even looked at the exam, so I don't know how you guys did. Okay. The other section did pretty well, which can probably tell me that there was some inside information arriving to the second section, since I didn't change a single comma of the exam. It was exactly the same. But that doesn't mean that the next time it's going to be the same. And honestly, it doesn't worry me too much, because the next time I can swap the things around and see what happens, or I can just write 2 totally different exams. Yeah. So that being said, the ones that wrote it first obviously are the ones that had it harder. So that's why I'm going to be somewhat forgiven, like when it comes to the little details, but it has to be on the right track to give you partial marks. What else was I going to say? I totally got sidetracked. The activities has to be done. Yeah, engage, ask questions, but I totally lost what I was going to say. Oh, that I don't know how you guys did. I got lost.
Because we're talking about like how to be successful, and then you're talking about like the exams.
Yeah, I don't know exactly how you guys did. I saw like some struggle, to be honest, and I haven't looked at the exams, so I'm assuming that some didn't do that well.
I think it's just like what, I guess what you could have done more, or like what could have done.
Yeah.
Public thing to talk about or discuss. What made
I
it
know this
harder?
course is difficult at the beginning because you have to change the mindset. It's not a regular programming course. You have to understand the hardware and the software, but I don't know, is there anything else that we could do to improve for the remaining portion of the course for you to succeed?
And the question is it hard because you don't know what to do, or is it hard because it's tricky?
It's very tricky, yeah.
I'd say maybe more formal activities.
Mm-hmm.
Like the challenges that you've been saying, but maybe we must be doing it in class?
Sorry, that's the part that I know. Thank you for that because it brought back what I was gonna say. I think the key for the ones that didn't succeed in this exam without even looking at the exam yet is that you didn't work in the assignments. And I can tell that because I saw like very little checkoffs before the exam, whereas all the feedback should be given before the exam. So you should be calling me over and asking me questions about. But if you're working in the assignments 2 days before the exam, it's too late. That's not the way it works for this course. It's already too late. You need to work in the activities as soon as they're released. And when I give you the due dates, although I'm not hard on the due dates, but that is the expected due date, is where you should be at. If you submit or get a checkoff after that, you're already behind. And I'm gonna be okay with it, but it's under your responsibility because you're adults. And yeah, unfortunately, I cannot treat you like you were high school kids and then force you to submit that day because you're all adults. It's on you.
Can I also add into that? I don't know if you mentioned this, but if you actually do your assignments earlier, you can get feedback from Carlos.
Yeah.
Like how to do it better, so.
That's the whole point, right? So when you get the checkoff, I can tell you, you could have done this differently. Why did you do this like this? But if you don't get any feedback, then you're so unprepared. Yeah, and you're right. And that's why I want to do more activities. But at the same time, when I do the activities, only a few stay, and the other ones decide to leave. I'm not going to give you the look if you leave because you are adults. But it's you that you're just letting your chance go. Right? If you sit, sometimes you stay too, but you sit there and do nothing. So that also doesn't work. I told you can work in groups, collaborate, okay? That's how you figure out things. All right. Anything else? Okay, so we will have some time to discuss the clock so we don't fall behind the other class too much. So we do have a demo. Before we talk about the clock, the latest demo that we have, let me just take a look here. It's called Speed Demo. Oh, beautiful. I think I pushed this one to the wrong repo. That is absolutely beautiful. Or maybe it is that. Oh, this is an detached head. Okay, let me see. Yeah, I committed